All right, guys, there we got composition of functions. We're going to combine functions together. Kind of hard to come up with a great real-life example of how this is going to make sense to you, a whole lot of what we're doing, so I'm going to try here. The best example I found was, look at this one right here. I don't know what just happened right there. Sorry about that. The example, the amount that a person pays as income tax is usually depends on the amount of adjusted gross income, which in turn depends on his or her annual earnings. So there's a lot of things involved there that determine this amount right here. So you're really combining functions as far as the gross income and annual earnings to get the amount that a person pays in income tax. And that's kind of what we're going to do with functions. We're going to combine some functions together to using an output of one. We'll look at the next sentence. It explains it better than I can try to talk right here. It says the output of a function sometimes depends on some input that is itself an output of another function. And that's probably clear as mud, but I want to at least give it a shot as far as explaining to you exactly what's going on today. Now, it's going to make more sense once you see 2 or 3 examples coming up, but that's kind of where we're going. All right, composition of functions. The composite function, you read this f of g. It's not a fog. It's not f-o-g. It's f with a little circle g. The composition of f and g is defined as this. F of g of x, same thing as f of g of x. Both of those you can write them either way. Both mean the same thing. Domain is important, where x is in the domain of g, so the domain in here, and g of x is in the domain of f. And we'll get to that in a second, exactly what that means. Okay, let's try a couple here. Okay, given that f of x is 2x minus 5 and g of x is x squared minus 3x plus 8, find each of the following. The first one, part A, says find f of g. So I'm going to find this first. Whenever it says find f of g, basically what you do is you're going to plug function g into f. So I'm taking this function right here and putting it into function f. So I'm putting the x squared minus 3x plus 8 where the x was. And I'm going to work that out as far as I can. I'm going to distribute the 2 and then simplify as much as I can. The only thing I can really simplify there is the 16 minus 5, which is 11. All right. It also says in the same part of the problem to do g of f of x. In this case, I'm going to put f into g. I'm putting function f into g. Everywhere I see an x, I'm going to put a 2x minus 5. So I'm going to 2x minus 5 squared minus 3 times 2x minus 5 plus 8. And I got to work all that out. This is going to take a second. Remember, when you square one, you square the first, you multiply together double, and you square the second. Distribute the negative 3, and I have that plus 8. Now I'm going to simplify as much as I can. 4x squared minus 26x plus 48. That's as far as I can go on that one. That's part A, believe it or not. Okay, part B says to find f of g of 7, which means I'm going to take 7 and plug it in f of g, which I just did right here. So it's going to look like this. It's going to be 2 times 7 squared minus 6 times 7 plus 11. That's 98 minus 42 plus 11. 109 minus 42, that's going to be 67. So there's f of g of 7. It also says to find g of f of 7. So I also got to find g of f of 7, which means I'm going to plug 7 into g of f, which is right here. So wherever I see an x, I'm going to put a 7. 4 times 7 squared minus 26 times 7 plus 48. Running out of room right there. I'm going to punch it in my calculator. That's a little bit beyond my doing it in my head possibility. 4 times really 49 minus 26 times 7 plus 48. And I got 62. All right, now, and that's all you're going to do there for A and B. Now, part C, I'm not going to do these two because I'm out of room. Plus, this is really the same thing. It says find g of 1. So I'll take function g and plug it into g where the x's are. Part D, f of f, I'm going to take 2x minus 5 and plug it in for that x. I'm basically plugging one function into another, or in this case, plugging one function into the same function for those two. So we'll work on that a little bit tomorrow, but that's basically what we're doing. Let me show you one more. It says given that f of x is the square root of x and g of x is x minus 3, find them again. Find f of g. To find f of g, I'm going to take g, plug it into f. So that's very simple this time. It's just going to be square root of x minus 3. And sometimes they are that quick. G of f, I'm going to plug function f into g. Always kind of go backwards. And if I put that in there, I get square root of x minus 3. Those are the two. That's part A. Then part B says find the domain of both of them. So the domain of the first one of f of g, the domain. First of all, when you do domain, you always start with what the second letter is. It's G. So I'm looking at this right here. The domain there is really all real numbers. So you can use anything there because there's no square root, there's no fraction. And so when I put this in here, the domain of this one would be x has to be greater than or equal to 0 because it's a square root. So when I get here, I have to look at both of those. I'm thinking, okay, what part of this domain is included in this domain and works in here? So what's got to be true there is my square root has to be greater than or equal to 0. So I'm going to take my x minus 3. And, okay, it has to be greater than or equal to 0. So if I move the 3 over, there's my domain right there. My domain is greater than or equal to 3. If you wrote it in an interval, you'd write it like this, 3 to infinity. Okay, the second part, domain of this one, do the same thing. You already got both domains up here. So I'm looking again at what part of this domain is included here. The difference here is the 3 is not inside, so really the only thing I'm restricted for is my square root. So in this one I can just say, okay, x is greater than or equal to 0 because everything else is fine. So if you wrote it as an interval, you write it just like this, 0 to infinity. So you need to look at domain when you start, look at your original domain for each function, and then also look when you get your final composition and see how you need to restrict it even further. But it has to be, it has to be included in your original domains. We're just going to restrict those two when we need to. All right, the last thing, decomposing a function. What they're going to do, the last thing is they're going to give you a function like this and make you come up with an f of x and a g of x, that if you did f of g, if you worked this out, you would get back to that right there. It's really going backwards. And one catch here, and here's what they will not let you do. You can't use this. You can't use what's called the identity. You can't use just x either time. But what you can do is this right here. You can say, like, for example, I'm going to say f of x is this, like it's x to the 5th. And I'm going to say g of x is 2x minus 3. And think about this. If I do f of g, if I take my function g and plug it into function f right there, it would be 2x minus 3 to the 5th power, which I wanted. So I hope that makes some sense going backwards. Let me show you one more just to make sure. Same thing here. Okay, you're looking at this function right here first. You're looking at the one right there. And you got to come up with an f of x and a g of x to where if you do the composition, you end up right here. And again, you can't just use x. So use the next best thing. Like use, I don't know, use something like 1 over x cubed here. And then down here put x plus 3. And I'll be honest, there's not just one answer to these. All right, there's a lot of answers you could do. But that's probably the easiest one. And just check it by doing this. Think about f of g, which means you'd plug in g into f. So if I plug that function into there, would it be that? And the answer is yes, it would. So that's it. And so going backwards a little bit there, it's called decomposition of functions. So hope that made some sense. We'll work on it in class like we always do. And I'll see you tomorrow. Look forward to it.